So one of the things I wanted to do for you is kind of show you a kind of real world example on how you'd open a file and use it. This one, you're not necessarily going to be tested on. So if you don't want to just watch this video, that'd be fine. Um, I've been trying to get to a little bit more real world examples, and somebody also had that up on the Q&A, so I figured I'd just go ahead and do one here. This is kind of scratching the past. I used to be a mechanical engineer, and we used to create these input decks to run these codes. And the input, there's two ways to make an input deck. One is to make it extremely structured, where you can get the information, know exactly where the information is in the exact spot. The other way is to make it less structured, but kind of keep a format so that people can read it fairly easily, and they can write it easily. And so this is going to be a little bit more towards the latter. So in this code, what I have here, or output, I have output and an FE file. Both these essentially are files where I'm going to either write information or grab information from. Then I have these two materials that I'm going to supposedly use in my run. Now, in the real world, obviously, this would be a much longer input deck, but I wanted to just show you kind of how you can grab materials here. And the first thing you want to do is something of this nature, and I'm going to run through it now. I'll just kind of highlight it as I go through. The first part should not be that um, different from what you've seen. So we got the with and the as. We're going to use an absolute path to find my input deck, and we're going to rename it input file as long as it stays inside Python. Then you got a for line, and again, this is probably something we've seen before because we've done it in other videos, where we're going to go through each line in this deck. And then we're going to look for the word mat, or maybe material might be better in this case, because ultimately what we're going to do is try to grab material data out of it and use it. And we grab it from a line. So nothing major other than the fact that we're looking for this string in each line. If I find it, that would make this true, and then we're going to split up that line to a list. And then I'm just going to print. That's just essentially give us some comfort level that we're finding the right stuff. We're going to actually replace that later. And then I do I from 0 to 2 by ones, because if you look, every time I have material, I have 3 different things underneath it. We can change that later to 4. Sometimes you'd actually might even put that in the input deck on how many lines to read after that, but we're going to just be a little rote there and go for it. Now here's the weird thing. I don't necessarily always suggest this, putting a 4 line in an input file. So this has a 2 and 9 are very similar, but what I want it to do is keep reading from that file. So if it's going to read something once here, and then it's going to read it again and push it forward, because now that we've read something, we found material, we want to read the next 3 lines afterwards. So that's how we're going to get to do it, and we're going to use that same dark and light. I use those variables loosely just to show you what I've been pulling out. So maybe I should highlight that then. Keep reading the file and get the 3 properties of the material. And then at last you'll see break because I want to kick out of this for statement. I don't want to keep reading to the end. I want to essentially let this for statement take over and read the next, look for the next material. So let's give it a quick run. You'll see that it has kind of cool results. It reads material 1, which is coming from the print dark, and then I'll read the next 3, name, water, coefficient, density. It'll break out of there, come back up to material, find material 2, and get those next 3. And they're all in order, and they're all nice and listed out. Now, why would I want to do that? Well, because I'm going to take this information into my code and maybe use it later, right? But it's almost there. We just maybe need to group it differently. So since I have material and we have 1, then I could actually do an if statement somewhere in here. In fact, I'm going to highlight this out, and maybe you can see the difference in that we just lose the materials. So we know it's grabbing the materials correctly. But what I really want to do is do an if here. So in other words, okay, so I ended up chopping off, and you might see a little bit of a jump here, the last video because I was just typing so much, making typos, and it's taken forever. So I figured I'd just cut to the chase and bring this to you here. Basically what I did is I created 3 lists. One was density, name, and coefficient to correspond to these guys. And I, going back to what we did, really all that I did was add this. So I take it back. I added this, and then I took out the print statements because we knew we were getting the right print stuff. So now all I needed to do was evaluate what was coming in, and I just have a simple if statement. If light 0 is equal to density, well, remember what light 0 is here. This, after we find material 1, it'll go to the next block and it'll look for 2 pieces of light because we split light into 1, 2, or maybe better put, the 0th part of the list and the first part of the list. So light 0 is going to check against these 3 things, and they don't necessarily have to be in order, so it might be a little bit more friendly for our user. And if it finds that, then it's going to take that information, like light 1 here, which is in this case here. Actually, let's go with the density. So density is down here. It's going to take density and change it into a float. Now I use dark 1 up here because dark is what has been established as the material piece. So dark, what do we say? Dark 1 is actually this material, and then I subtract 1 off of it because most people are going to start their materials at 1. In fact, we could just specify that, and so I subtract 1 off, so it starts at 0 and then gets put into the 0 slot. I do the same thing for coefficient. The only thing different that I'm going to do with name is that I don't have to change it into a float because it's already a string. The name is already a list of characters. It is not an actual number that we might use. And then that populates this dark 1, or more importantly, the density coefficient and name. So when I run this, I end up receiving densities, all the densities together with the zeros. And if you use arrays, it might work a little better. You can always check for zeros and remove them later. This is just the byproduct of the fact that I started off with a 3-part array because I didn't want to go out of the out of the list, because I didn't want to go out of the bounds of the list. But you can see the densities are together, the coefficients are together, and the names are together, and they're in order. So it's water, steel, because water was 1 and steel was 1. Now the beautiful part of this is I could do change it here, as long as I have a little bit of formatting. So in other words, material states where material stuff is, I can do this. So don't put these in order. The materials are not in order. I'm going to hit save. And then if I hit start, I should see the exact same output as before. It keeps all the one in the first, material one in the first spot. It does not get thrown off by the materials names, and all the coefficients are grouped together again. So this, this is just one way of kind of using what we've learned so far, um, in kind of essentially a grander read file kind of claim, where you can let people make things for maybe a future program that you use.